So far we've been able to set up a linked list with 3 nodes, and you saw how easy it was to make mistakes, that is to have too many or maybe too few levels of these links. And you can see this is just not going to be something that will scale up. That is, if you have, let's say, 100 locations in your array, how can you add this? You'll end up with a huge list of links. And so definitely this is not the way to do things. But this is just a way to show you that you can actually set up a linked list with just straight sequential code. But what you will need to do as soon as we want to set up some functions that will accomplish some of these tasks. That is, maybe inserting things into a list. So the kinds of things we want to do is like this. We want to set up some kind of function where you create a new node, and then we say head arrow data is equal to AR sub 0. That's fine. But what we want to do after that is we want to say something like this: insert a new node. And really, we don't really care about the nodes themselves. All we want to care about is our data. So let's say we put in AR sub 0. Now we just want to insert AR sub 1. I mean, that's really all this is accomplishing, this big complicated statement. And then this third statement, all that's really accomplishing is insert AR sub 2. And you can see where this is going. If this works, if we are able to get this insert method to work, we can put this in a loop and just add stuff to this linked list using a loop. And we won't have to set up this kind of stuff. So let's just assume that we're going to be able to do that. We're going to get this insert thing to work, and assume that we can just do that. So where will this insert put things into? It turns out, well, there's not enough information. So we'll have to say, I want to insert to this head node. Okay, so I want to insert something, insert an int into this list that's pointed to by head. And it turns out we don't need this either. So we can just say node head, and then we will start out with head being equal to null. And that's always a good thing to do with pointers. Initialize all pointers to null. Even if you're going to set it right away, you want to say I want to initialize all pointers equal to null. Okay, so if we can do this, right, this is our goal. If we can say initialize head to null and insert the 0th element of the array, the first element, the second element, and so on, then we don't have to deal with all of those chain of links and messing up the number of links and so on. So let's try to get this thing to work. Now it turns out the easiest way to set up insert is to actually add things to the front of the list every time. All right, and so not to the back of the list. So what will happen is we'll add the 10, then we'll add 3 to the front of the list, and add 2 to the front of the list. And so when we print it out, it'll actually end up being backwards. It'll print out 2, 3, 10. And so later on, we'll see how to insert it the right way. That is in the same order that we insert. Okay, so here's a first shot. Let's try this. We'll set up a void method called insert, and we will say node star p, and then int value that we're gonna insert into the first node that we can put into. Okay, so now here's how we would set it up. This is just one way of doing it. There's many ways. We'll set up a temp pointer, and so this is one thing you want to avoid. I see a lot of people do this. That is, when you set up a temp pointer, a lot of people initialize it not equal to null, which is what you should do, but equal to some new node. And you don't need to do that right away, not always. Okay, so here's what most of the time this will work. You say temp node, node star temp is equal to null. That's a good place to start usually. Okay, so now we have a node, a pointer to a node that's set equal to null. Now, what we want to do is check if p is equal to null or not. If it is equal to null, we might have to do something special. Otherwise, we can say that if p is pointing to a new node, we want to create a new node, have the next, or the link data member of that new node point to what p used to point to, or have it point to p. Alright, so here's how you do it. Temp is equal to new node. Alright, this is the kind of thing we did before, and we're going to say temp arrow data is equal to whatever data as int we get. And you say temp arrow link is equal to p, whatever p is pointing to. Doesn't matter if it's null or not, it turns out. So you can try that out. We'll check it out. And then finally, we have to have some way of saying now that we have a new head pointer. Now this is the hard part, because now let's take a look at this and let's just try to debug this. It turns out this will not work. Compile it, it'll actually compile, I believe. Oops. Insert, oh yeah, we need a function prototype like we did earlier with print. If say insert has two parameters, a pointer to node and an int. Okay, got that now. I'm hoping it'll compile. Okay, it compiled. Now this is not, it turns out this by itself is not going to work, and let's see why. It's very interesting, very good example to go through. Let's go into the debugger. Okay, so we're going to print out this first line of text, and then set up the array, and we initialize head to null. Now here's where we need to step into here, this function. Insert. Alright, we're going to create a node, and I would say, just to keep things easy, even though we don't have to do this, I would say whenever you set up and declare something that's a pointer, always initialize it to null. Do not initialize it to a new node. Even though you might do it in the very next step, always initialize pointer to null. That's just the best way to do things. Now, this time around, in this case, we are pretty certain that we need to create a new node, because that's what we want to do in this insert. We want to create a new node with this int v in there. So we set the data member of this new node to v. And now we're going to have temp arrow link set to whatever p was pointing to. And we know that p was null. So it turns out this is not going to work, because now you create a new node, we put in the value v, you have the new node pointing to what head used to point to, which is null. And so we created a node. But the fact is, when you exit from here, when you return from this function, and let's just do that, head will still have the same value that it had before. And you can check here, look at this, head is equal to null. So we're gonna, if we do this one more time, you get this exactly the same result. You're going to create a new node with this value, that's the second location of this array, and then we return from the this function, and it turns out head is not changed. Head will still be null. So what can you do about this? Well, there's a couple of ways to do this. One would be to use pass by reference of this pointer so that we can change the pointer. Now it's a little complicated, and it'll work. It will work, but let's try this. Let's say node star. This is going to return a new node, and so what we're going to do is say head is equal to insert this new node at the head location. Okay, and we'll do the same thing again, and this will work. Of course, it would be just as you could do this by passing in pass by reference a pointer, and then you could change p inside this function, but let's keep it simple. Okay, so here what we're going to do is we're going to return temp, this new node that we created in here. Now on the surface this might look like, well, this could be asking for trouble because temp is allocated on the stack. That's sure, that's right, but what we're interested in is the new node struct that we allocate, and that's allocated on the heap, so returning temp is actually not a problem. So let's try this. Okay, we're going to say head is equal to insert at head relocation 0, and then the same thing with the third. Okay, and let's get out of this debugger. Okay, and let's just assume this is going to work. It might not work. There might be some bugs. This is with linked lists. It's always everything looks okay until you run it. All right, compile it. Ooh, tons of errors. Oh, I forgot to change my function prototype. Now I'm returning a node. Let's compile this. And let's run it, see what happens. Well, it worked. Surprise. Okay, so as we said before, since we're inserting at the head, this is the easy way to do things. That is, we create a new node. We have the linked data member point to whatever p pointed to, and we're going to pass in head each time. And then we return temp, this new node, pointed to the new node we created, as the return value, and then we set head is equal to that new node that we just created. So when you do this, so you might want to stare at this, make sure it all makes sense, step through some code like this in the debugger. When you do something like this, head is equal to insert head AR sub 0, what you're really doing is you're passing in head as a parameter, and it can't change, and so we take whatever insert returns and store that into that head pointer. Okay, so I'll stop here, and you might want to try out code like this. You might want to pause the video, make sure you set up these insert and print functions, use them, and then what you want to do next after that is set up a loop, and it will be something like this. For int I equals 0, and in this case I less than 3, because we only have 3 elements, I plus plus, and here's the final step in making all of that code easier to use. So there we go. So now we'll put AR sub 0, AR sub 1, AR sub 2. We have a nice loop. And this will work for any number. If you had 100,000 elements in this array, just put I less than 100,000, and all of this will work. No problems.